So this is 2.6. Again, this is, you're going to see that this is something we've covered in the past. So these are rational polynomials. Okay, do you guys remember what rational means in math?
Real number?
Real numbers are rational. Not all real numbers are rational. Pi isn't rational. Square root of 2 isn't rational.
Whole numbers?
All whole numbers are rational, but that still doesn't quite give me the definition.
Non-infinite,
They could be repeating. Here's how you would have learned it in the past. Anything that can be written as a over b, where a and b are both integers, that's a rational number. So like 2/3 is rational. I can write it as a fraction, 2 over 3, and 2 is an integer and 3 is an integer. The number 4 is rational because I can write it as 4 over 1. But pi cannot be written as a fraction. Square root of 2 cannot be written as a fraction. So those are not rational. So where we're going to start today, the first thing we're going to talk about, and again, this is review, we've covered this before, horizontal asymptote. Do we remember what an asymptote is?
Isn't it when it comes close to that line?
Yeah, it's a line, so horizontal. It's in this case, a horizontal line that a function, and it could be from the top or the bottom, and left or right, gets close to a line, but never touches it. So if I go off to infinity in this direction, and I keep zooming in, there will always be space between my graph and this asymptote. Bless you.
Thank you.
Okay? Does that make sense? Do we remember that? Okay. All right. So a horizontal asymptote, there are 3 scenarios. Okay? First scenario I'll talk about, and again, these are all rational functions, which means they're just fractions. I'm going to put x to the 3rd on top, and I'm just making this one up, over 4x squared minus 5x plus 2. So there's 3 scenarios for horizontal asymptote. This first scenario, and all you ever do is look for the biggest, where is the biggest exponent? Is it starting to jog your memories? Is it starting to come back at all? No, not at all. Okay, so where is the biggest exponent? And in this case, where is the biggest exponent? It's on top. When it's on top, like it is in this case, so when it's on top, we have no horizontal asymptote. No horizontal asymptote. I'll just leave it as no horizontal. Okay? Well, we have, like I said, we have 3 scenarios. This is when it's on top. What about when it's on the bottom? Put it over here. So again, I'm just making up a random fraction. I can even have the same top. But this time on the bottom we have like 3x to the 7th plus 2x to the 3rd and so on. It doesn't matter. Where is the biggest exponent this time?
Bottom.
The bottom. When it's on the bottom, y equals 0 is your horizontal asymptote. Anytime the biggest exponent is on the bottom. In this case, it's 7. On the top, we just have a 3. So the horizontal asymptote, when the biggest exponent is on the bottom, is always just y equals 0. Now are we remembering or no? Still no? What's our last scenario?
They're equal.
When it's the same on top, same on the bottom. So f of x, I'll go 2x to the 3rd plus 2x over 5x to the 3rd minus 7x squared Okay, in this case I have a 3 on top and a 3 on the bottom. It's the same on the top and the bottom. What is our horizontal asymptote this time?
X equals 0.
No. Hang on.
3.
It's not 3.
1.
It's not 1.
6.
It's 2. Yo, you do remember. It's 2/5. Okay, we look at the coefficients that have the biggest exponent, and we write that as a fraction, and we reduce if possible. Okay? Make sense? Yeah? No? Okay. We ended up first hour only doing one example because that pretty much covered all the examples. If you guys need, I'll probably just do one for the taping here, but if you guys need me to go through another example, I will. So the example, well, in fact, let's just look at example 2. We'll just cover horizontal asymptotes with those two. If you look, because it'll get to the point where you just have to look at a function and you should be able to tell what the horizontal asymptote is. So if I look at example 2, A, this is on page 168. Example 2A. What do you guys think that horizontal asymptote will be?
2.
Yeah, well, no.
2.
Just y equals, it'll be y equals 2.
Yeah. Just looking at that. What's that woman?
It was definitely 2/5 up here.
Oh, okay, yeah.
Yep. Example 2A, it should just be 2, because on top we have x squared, on the bottom we have x squared, and the coefficients are 2/1. Okay, how about B?
It's 1.
Y equals 1. And you gotta make sure you put the y equals because it is a line. Y equals 1. Page 168. Good? Okay, and again, and you can just practice, like go through the assignment. You just be able to look at the problem and get the horizontal asymptote. That one's the easy one. Actually, they're all kind of easy if you.
Shut up.
Okay. I hope that wasn't directed at me.
For their intellectual abilities.
All right. Moving on. Okay, so I'm gonna write. I'm gonna base this whole lesson on just example 2B. So it's x squared plus x minus 2 over x squared minus x minus 6. Okay, so there's 5 things we need to find in this. The first one, horizontal asymptote. Second one is domain. The third one is y-intercept. The fourth one is, yes, we did, vertical asymptote. And the fifth one is the x-intercept. So, horizontal asymptote, what is it?
1.
Good.
Second y.
Yep, y equals 1, good. Whoops, then I wrote 0. Y equals 1. Okay? Typically, the second thing to find, the second easiest thing to find, so this is the first thing. The second thing is the y-intercept. This is the order I usually do these problems. Horizontal asymptote, and I won't be able to write out everything on this board this time because it's just a little bit goofy, but hopefully you can hear what I'm saying. Y-intercept, but this is the same thing we've done for all y-intercepts.
1/3.
What are you doing?
-2 over -6.
But what are you actually doing? You're putting a 0 into x. So set x equal to 0, put that in. If I put a 0 into the x squared on top, that's 0. 0 into the x on top, it's 0. I just get -2 over -6 after all the x's get zeros. So I end up, and y-intercept is a point. So when x is 0, y is 1/3. So far, so good. Okay, next we'll do the domain. In order to do the domain, we have to figure out when the bottom equals 0. When does the bottom equal 0? Before we reduce. Before reducing. So what does that mean? First thing we're going to do is factor. Can we factor the top? We can. What is the top factor 2? What is it?
X minus 3x plus 2.
So what multiplies to 2?
X.
I think you're doing the bottom.
Yeah.
Okay, I was doing the top. 2 and 1, correct? Which one gets the plus sign?
2.
Or the, yeah, you're right.
Yeah, 2
My bad. Okay, good. And then what does the bottom factor 2?
X minus 3x plus 2.
X minus 3, x plus 2. Okay, now the domain happens before we reduce. Can I reduce this? I can. The 2x plus 2's would cancel. But for domain, we look at the bottom. When would the bottom be 0? And that's our answer for the domain. So when would the bottom be 0? All real numbers. Domain is all real numbers. Except what can't x equal?
3 or negative 2.
3 or negative 2. So before we reduce. Okay? So these 3 are all kind of in order. The first one, you should just be able to look at it. Second one, pretty much again, you should just be able to look at it. The third one, domain, you're going to have to factor it. And then when is the bottom equal to 0? But that's before reducing. This is critical. Before reducing. Now these last 2, we're going to reduce it. Well, to reduce it, whoops, that wasn't right. To reduce it, these 2x plus 2's cancel out. Right? Because if you have x plus 2 on the top, you have x plus 2 on the bottom, that divides to 1. With me? Okay, so the next one I typically find is the vertical asymptote. And I guess these last 2, usually the order doesn't necessarily matter, but we'll do vertical asymptote. And this is when the bottom equals 0 after reducing. So we've reduced it. What would make the bottom 0? What? 3. And it's a line, just like the horizontal asymptote is a line. So this will be an equation. So we keep an x in there. When x equals 3, we have a vertical asymptote. Because that's when the bottom would be 0. If I put a 3 into x, I get a 0 in the denominator. So far, so good? Okay, last one, x-intercept. I'll just put a line here to... Oh, that is messy. This is when, after reducing, I won't rewrite it, but this is after reducing, again, this is when the top equals 0. So what x value would make the top equal to 0 after we reduce?
1.
Just the number 1. And it's an intercept, so it's a point. You could maybe write that off to the side. This will be a point. This will be a line, equation of a line. This will be a point here. And then this is a line here. That's hopefully followed step by step. If you, even for you in the class, if this doesn't make any sense, you could always watch this again. Hopefully this pulls up on the Google Doc. But I'm gonna end the video.